the universe, infinite, eternal, before time, before light. There was nothing, an immeasurable void, silent and still. Then, from an infinitely dense point, an explosion, the Big Bang, a blinding flash of energy erupting into the nothing. The universe, newborn and violent, began to expand. It cooled, transforming energy into matter. Subatomic particles, the building blocks of everything, materialized in the seething chaos. Imagine a darkness so profound it could swallow light itself. This was the early universe, a realm of unimaginable energy and terrifying beauty, a maelstrom of creation birthing the seeds of galaxies, stars, and worlds. But within this cosmic tempest, a profound silence reigned. For in the vacuum of space, sound cannot exist. Only the faint echo of creation reverberated through the expanding universe.
As the universe expanded, it cooled. Energy, once a chaotic inferno, began to coalesce. Subatomic particles, drawn together by forces unseen, formed the first atoms, hydrogen and helium. The universe, once a blinding flash, now glowed with a faint ethereal luminescence. This ethereal glow, a whisper of creation, still reaches us today. Scientists peering back through time detect this faint echo in the form of cosmic microwave background radiation, a ghostly reminder of the universe's violent birth. From this faint glow, the universe began to take shape. Gravity, the architect of the cosmos, began to exert its pull. Hydrogen and helium, drawn together, formed massive clouds, swirling and churning in the vastness of space. These clouds, colossal and cold, became the nurseries of stars. Within their depths, gravity ignited a cosmic dance. Atoms, squeezed together under unimaginable pressure, began to fuse. Nuclear fusion, the heart of stars, illuminated the universe.
The first stars ignited, blazing with ferocious energy. These stellar giants, far larger and hotter than our own sun, bathed the universe in a new light. Their intense radiation carved out vast cavities in the surrounding gas clouds, sculpting the first structures in the cosmos. But these early stars were short-lived. They burned through their fuel quickly, ending their lives in spectacular supernovae. These cosmic explosions scattered heavy elements, forged in the hearts of stars, across the universe. These scattered elements, the building blocks of planets and life itself, enriched the surrounding gas clouds. The universe, once dominated by hydrogen and helium, now possessed a rich tapestry of elements. The stage was set for the formation of planets.
In the aftermath of supernovae, within the swirling clouds of gas and dust, a new dance began. Gravity, ever vigilant, drew particles together. Dust grains, remnants of dead stars, collided and stuck together. Slowly, infinitesimally they grew. Imagine a realm of perpetual twilight, where shadows danced among swirling dust. Rocks, drawn together by invisible forces, circled each other in a silent ballet. This was the beginning of planet formation, a slow and chaotic process playing out across the universe. These clumps of rock and dust, drawn together by gravity's pull, became the seeds of planets. Their growth was a story of collisions and accretion, a cosmic dance of creation and destruction.
Imagine the early solar system, a chaotic disk of gas and dust swirling around a newborn star. Within this disk, a cosmic mosh pit raged. Countless particles, from microscopic grains to mountain-sized boulders, collided and crashed. It was a chaotic ballet of creation and destruction, a symphony of impacts echoing through the void. Each collision, a spark of energy released in the darkness. Dust grains, once floating freely, now clung together, bound by static electricity and the faintest whispers of gravity. Every impact, a tiny step towards order in the chaotic abyss. Think of a billiard table after the first powerful break. Balls careen wildly, bouncing off each other, and the rails in a chaotic dance. But with each collision, some of that frenetic energy dissipates, and slowly, order begins to emerge. So it was in the early solar system, where the chaotic movements of countless particles gradually gave rise to larger and larger bodies. This chaotic dance wasn't confined to a single plane either. Imagine particles swirling, not just in a flat disk, but in 3 dimensions, like a swarm of angry bees surrounding a hive. Collisions happened from all directions, a chaotic ballet of cosmic proportions.
Each impact, a tiny explosion, a release of energy that rippled through the surrounding dust and gas. Most collisions were glancing blows, nudging particles into new trajectories, adding to the chaos. But some, by chance, struck head-on. These were the collisions that mattered, the ones that built planets from dust. Imagine two boulders hurtling towards each other at unimaginable speeds. The moment of impact, a blinding flash, a shockwave that reverberates through the void. The two boulders shattered into a million pieces, yet some fragments remained, fused together by the heat of the impact. This is the process of accretion, the gradual accumulation of matter through collisions. It's a slow, messy process, but over millions of years it transformed the chaotic disk into a more ordered system. Imagine a child with a set of building blocks, at first just scattering them randomly, then gradually beginning to stack them, one on top of another, creating larger and more complex structures. In much the same way, gravity and chance collisions were the invisible hands that assembled the planets from the building blocks of the early solar system. It was a chaotic symphony of impacts, a relentless barrage of cosmic shrapnel. But within this chaos, a beautiful order was slowly emerging.
Over time, these larger clumps of matter, now meters across, began to exert their own gravitational pull. They moved through the disk like cosmic vacuum cleaners, sweeping up smaller particles in their path. These larger bodies, the precursors to planets, are called planetesimals. Imagine a snowball rolling down a hill, gathering more snow as it goes, growing larger and larger. That's essentially how planetesimals grew. Their increasing gravity pulled in more material, accelerating their growth. These planetesimals were not uniform, though. Some were rich in rock and metals forged in the hearts of dead stars. Others were composed mostly of ices, frozen water, methane, and ammonia, remnants of the cold outer reaches of the protoplanetary disk. Imagine a cosmic stew simmering in the heat of the newborn sun. Ingredients once scattered and chaotic began to clump together, forming distinct flavors and textures. Rocky planetesimals formed closer to the sun, where the heat drove away volatile ices. Icy planetesimals formed farther out, in the cold depths of the disk, where ices could survive. The stage was set for the formation of planets, but the process was far from over. The real violence was just beginning.
As planetesimals grew larger, their gravitational pull intensified. They became like cosmic bullies, muscling their way through the protoplanetary disk, attracting and absorbing smaller objects. These weren't mere collisions anymore, but cataclysmic events that reshaped the solar system. Imagine a bowling ball crashing into a pyramid of delicate glassware. The result, a catastrophic cascade of shattering glass, a chaotic release of energy. This is the scale of destruction that accompanied the growth of planets. These collisions weren't just destructive, however. They were also acts of creation. The energy released in these impacts melted rock and metal, creating molten worlds with fiery volcanic surfaces. Some collisions were so violent that they ripped material from the colliding bodies, forming rings of debris that circled the newborn planets. The early solar system was a shooting gallery, with planetesimals and protoplanets on a collision course dictated by gravity and chance. Each impact sent shockwaves through the disk, nudging other objects into new orbits, further fueling the chaos.
The dance of gravity is a subtle one, a slow waltz across vast distances. Yet, it's a powerful force, capable of sculpting solar systems and flinging planets from their stars. In the crowded early solar system, gravity was the choreographer of a chaotic yet beautiful ballet. Imagine a giant game of cosmic billiards with planets as the balls and gravity as the cue stick. Each collision, a change in trajectory, a new path carved through the protoplanetary disk. Some planets were flung outwards into the cold depths of interstellar space. Others migrated inwards, drawn towards the intense heat of the sun. This gravitational dance wasn't just about collisions. It also influenced the composition of planets. Giant planets like Jupiter and Saturn, with their powerful gravitational fields, acted like cosmic vacuum cleaners, drawing in vast amounts of gas and dust. This is why the gas giants reside in the outer solar system, where ices and volatiles were plentiful. Closer to the Sun, where the heat was too intense for ices to survive, rocky planets like Earth and Mars formed. These planets, while smaller than their gas giant cousins, were no less shaped by the gravitational dance.
Over millions of years, the chaos subsided. The once crowded protoplanetary disk thinned out, as planetesimals were either absorbed into planets or flung into the depths of space. The solar system, once a maelstrom of dust and colliding rocks, began to resemble the more ordered system we know today. The planets, now fully formed, continued to cool and evolve. Volcanic activity reshaped their surfaces, while the constant bombardment of asteroids and comets left their marks in the form of craters and scars. The birth of our solar system was a violent and chaotic affair. It was a time of cosmic collisions, gravitational battles, and the relentless cycle of creation and destruction. But from this chaos emerged order, a testament to the awesome power of gravity and the slow, steady march of time. The planets, silent giants orbiting a star, are the survivors of this epic cosmic drama.
The planets, once molten balls of fire and rock, began to cool. Their surfaces, scarred and molten, slowly solidified. But the violence of their birth left indelible marks, whispers of chaos etched into their very being. Look at the moon, our closest celestial neighbor. Its barren, cratered surface is a testament to the relentless bombardment that shaped the early solar system. Each crater, a frozen echo of a violent impact, a story written in rock and dust. These impacts, while destructive, also played a crucial role in shaping the planets we see today. They delivered water and other volatile compounds, essential ingredients for life as we know it. The very air we breathe, the water we drink, may owe their existence to these ancient cosmic collisions. Imagine a detective dusting for fingerprints at a crime scene. Each crater, each scar on a planet's surface is a clue, a fingerprint left by the chaotic forces that shaped our solar system. By studying these clues, we can piece together the story of our cosmic origins.
Consider the majestic rings of Saturn, a breathtaking display of cosmic beauty. These rings, composed of countless icy particles, are likely the remnants of a moon torn apart by Saturn's immense gravity, a testament to the power of these celestial giants and the violence that can lurk beneath their serene facades. Or look to Uranus, a planet tilted on its side, its rings circling it like a tilted halo. This peculiar tilt is thought to be the result of a catastrophic collision with a massive object early in its history, a cosmic hit-and-run that left an entire world forever scarred. These scars, far from being blemishes, tell a story of resilience and transformation. They remind us that the universe is not a static, unchanging place, but a dynamic, ever-evolving realm where violence and creation are often intertwined. Imagine a blacksmith forging a sword. Each blow of the hammer, while seemingly destructive, shapes and strengthens the metal, transforming it into a weapon of beauty and power. So it is with the universe, where catastrophic events can lead to unexpected and awe-inspiring outcomes.
Between the orbits of Mars and Jupiter lies the asteroid belt, a vast region populated by countless rocky remnants of the early solar system. These asteroids, ranging in size from pebbles to small worlds, are the leftover building blocks of planets, remnants of a chaotic past. This cosmic graveyard, far from being a place of stillness, is a dynamic and potentially dangerous region. Asteroids, nudged by the gravity of Jupiter and other planets, can be sent on erratic trajectories, some even crossing Earth's orbit. These near-Earth asteroids, while posing a potential threat, also offer a unique opportunity to study the raw materials from which our solar system formed. Imagine a vast junkyard filled with the discarded parts of countless machines. To the untrained eye, it may seem like a chaotic mess, but to an engineer or a mechanic, it's a treasure trove, a place where they can find the components they need to build something new. The asteroid belt is like a cosmic junkyard, containing clues to the composition and evolution of the early solar system. By studying these remnants, we can learn more about the processes that led to the formation of our planet and the emergence of life itself.
Section 4. Planetary Cataclysms. The Earth itself bears the scars of countless impacts. Craters, some visible, some hidden beneath layers of sediment and ice, tell the story of a planet bombarded by cosmic debris throughout its history. These impacts, while often destructive, have also shaped the course of life on Earth. The extinction of the dinosaurs, for example, is widely believed to have been caused by the impact of a massive asteroid. This catastrophic event, while wiping out the dominant life forms of the time, also paved the way for the rise of mammals and ultimately the evolution of humans. Imagine a forest fire raging through the undergrowth, consuming everything in its path. While seemingly destructive, the fire also clears away dead wood and underbrush, allowing new life to flourish. So it is with some cosmic impacts, which can act as agents of change, reshaping ecosystems and creating new opportunities for life to evolve. These cataclysmic events, while terrifying in their power, are also a reminder of the dynamic nature of our planet and the universe itself. They show us that change is inevitable, and that even the most catastrophic events can have unexpected and ultimately life-affirming consequences.
Section 5. When worlds collide. The formation of our own moon is thought to have been the result of a particularly violent collision early in Earth's history. A Mars-sized object, dubbed Theia, slammed into the young Earth, ripping off a chunk of its mantle and scattering debris into orbit. This debris, over time, coalesced under the force of gravity, forming the moon we see today. This titanic collision, while cataclysmic, had a profound impact on the evolution of Earth. The moon's gravity stabilized Earth's axial tilt, creating the regular seasons that allowed life to flourish. The tides, caused by the moon's gravitational pull, created a dynamic environment along coastlines, potentially playing a role in the emergence of life from the oceans. Imagine a potter molding clay on a wheel. The initial lump of clay is shapeless, but with each spin of the wheel and each deft touch of the potter's hand, it takes on a more defined form. The impact that formed the moon was like the potter's hand, shaping the Earth into the life-sustaining planet we know today. This event, a testament to the chaotic beauty of the early solar system, highlights the interconnectedness of celestial bodies and the profound influence they can have on each other's destinies.
Section 6. Out of the ashes. As the solar system matured, the frequency and intensity of these collisions decreased. The planets, having swept up most of the debris in their orbits, settled into more stable orbits. The era of planet formation, while not entirely over, had given way to a period of relative calm. But the peace is not absolute. Asteroids and comets, remnants of the early chaos, still pose a potential threat to planets. The scars on the surfaces of planets and moons serve as a constant reminder of the violent past and the ever-present potential for cosmic upheaval. Imagine a calm sea, the surface shimmering under a gentle breeze. Beneath the surface, however, currents swirl, and the ocean floor bears the marks of ancient storms. The solar system, while seemingly peaceful now, still harbors the potential for violence, a reminder that we live in a dynamic and ever-changing universe. The formation of planets is a story of both creation and destruction, a delicate balance between chaos and order. The planets we see today, with their diverse landscapes and unique characteristics, are the survivors of this epic cosmic drama, each bearing the scars of their violent birth.
Section 5. Planetary Migration. The solar system began to stretch and evolve under the influence of gravity. Planets embarked on journeys across the solar system, dictated by gravitational forces. Driven by gravitational interactions, planets migrated inward and outward over millions of years. This migration profoundly impacted the solar system's structure and evolution. Jupiter's inward migration scattered smaller objects like a cosmic snowplow. the solar system settled into ordered orbits, bearing the scars of its nomadic past.
Section 6. A cosmic shooting gallery. While the planets were taking shape, the space between them was far from empty. Countless asteroids, comets, and debris hurtled through the darkness, creating a cosmic shooting gallery. The early solar system was dangerous, with planets and moons bearing the scars of impacts. These impacts shaped planets and delivered essential ingredients for life. Comets brought water and organic molecules to early Earth, providing building blocks for life. This era of intense bombardment was essential in the evolution of the solar system.
Section 7. The Late Heavy Bombardment. About 500 million years after the planets formed, the solar system experienced intense bombardment. The inner solar system was pummeled by asteroids and comets, leaving craters and scars. One theory suggests giant planets destabilized asteroid orbits, sending them inward. Imagine a bowling ball scattering pins in all directions. The giant planets acted like cosmic bowling balls, disrupting smaller objects. Earth, in its infancy, was pummeled by impacts, some vaporizing oceans. The moon bears scars of this bombardment, a testament to ancient violence. These impacts delivered water and organic molecules, enriching the primordial soup. The late heavy bombardment shaped planets and set the stage for life on Earth.
The solar system, once a maelstrom of fire and ice, gradually settled into a period of relative calm. The planets, their orbits refined by gravity's patient hand, circled the sun in a stately cosmic ballet. The era of planet formation was drawing to a close, but the universe, ever restless, held on to whispers of its chaotic past. Imagine a pendulum, swinging back and forth, its energy slowly dissipating with each swing. The early solar system was like that pendulum, its initial chaos gradually giving way to a more ordered state. But just as the pendulum never truly stops, the potential for chaos in the solar system never entirely vanished. Asteroids, remnants of the planet-forming disk, still lurked in the darkness, their orbits influenced by the gravitational pull of the planets. Comets, icy messengers from the distant Oort cloud, occasionally plunged inward, their fiery tails illuminating the night sky as a reminder of the universe's unpredictable nature. The planets themselves, though seemingly static in their orbits, continued to evolve. Geological processes, driven by internal heat and the relentless pull of gravity, reshaped their surfaces, carving canyons, raising mountains, and spewing molten rock from volcanic vents. The solar system, though seemingly at peace, was far from static.
The Earth, our home, bears the scars of its violent past. Craters, some visible, some hidden beneath layers of sediment and ice, tell the story of a planet bombarded by cosmic debris throughout its history. These impacts, though often destructive, have also shaped the course of life on Earth. Consider the Chicxulub crater, a vast scar beneath the Yucatan Peninsula, evidence of the cataclysmic impact that wiped out the dinosaurs 66 million years ago. This single event, a cosmic blink of an eye, forever altered the course of evolution, paving the way for the rise of mammals and ultimately the emergence of humans. Or look to the moon, our constant companion. Its barren cratered surface, a stark reminder of the bombardment that shaped the early solar system. Each crater, a silent testament to the power of cosmic impacts, a story written in rock and dust. These whispers of ancient chaos serve as a reminder that we live in a dynamic and ever-changing universe. The peace we experience today is a fragile thing, a temporary respite in the grand cosmic drama. The universe, though often beautiful and serene, is also capable of unimaginable violence, a force that can reshape worlds and extinguish entire species in the blink of an eye.
But the universe is not just about destruction. It's also a place of incredible beauty, a vast cosmic ballet where celestial objects move and interact in ways that defy our imagination. Stars are born, live out their lives, and die in spectacular explosions that seed the universe with the building blocks of new stars and planets. Galaxies, vast islands of stars, gas and dust, collide and merge, their gravitational interactions triggering bursts of star formation that light up the cosmos with a kaleidoscope of colors. Black holes, enigmatic objects with gravitational pull so strong that not even light can escape, lurk at the centers of galaxies, influencing the evolution of their surroundings in ways we are only beginning to understand. The universe is a dynamic and ever-changing place, a cosmic dance of creation and destruction that has been playing out for billions of years. Our own solar system, though seemingly stable and serene, is just one small stage in this grand cosmic ballet, a fleeting moment in the vastness of space and time.
Even as our own solar system enjoys a period of relative peace, new worlds are being born in distant corners of the galaxy. Within giant clouds of gas and dust, known as nebulae, gravity is at work, pulling material together, igniting the fires of new stars. Imagine a cosmic nursery filled with the cries of newborn stars, their light illuminating the surrounding gas clouds in a breathtaking display of celestial fireworks. Within these stellar nurseries, the process of planet formation is repeating itself, playing out on a grand scale. Protoplanetary disks, swirling clouds of gas and dust, surround these newborn stars, their constituent particles colliding and clumping together, gradually forming larger and larger objects. Over millions of years, these objects will coalesce into planets, some rocky like Earth, others gas giants like Jupiter, each with its own unique characteristics, shaped by its distance from its star and the composition of the surrounding disk. The birth of planets is a chaotic and violent process, but it's also a testament to the creative power of the universe. From the ashes of dead stars, new worlds are born, each with the potential to harbor life and continue the cycle of cosmic evolution.
The universe is a place of constant change, a cycle of birth, death, and rebirth playing out on a cosmic scale. Stars, the building blocks of galaxies, are born from collapsing clouds of gas and dust, their intense heat and pressure forging heavier elements in their cores. As stars age, they eventually exhaust their nuclear fuel and die, some in spectacular supernova explosions that scatter their newly created elements into interstellar space. These elements, the raw materials of planets and life itself, enrich the surrounding gas clouds, seeding them with the ingredients for new generations of stars and planets. The death of one star, though seemingly an ending, is also a beginning. The scattered remnants of its core, enriched with heavy elements, will eventually be incorporated into new stars and planets, continuing the cycle of cosmic evolution. Our own solar system, formed from the ashes of countless dead stars, is a testament to this cycle of life and death in the universe.
The universe is vast and enigmatic, filled with wonders that we are only beginning to comprehend. The formation of planets, though a process we are beginning to understand, is just one small piece of the cosmic puzzle. Countless mysteries remain, waiting to be unlocked by future generations of scientists and explorers. Are we alone in the universe, or are there other planets out there teeming with life? What is the nature of dark matter and dark energy, the mysterious substances that make up the vast majority of the universe's mass and energy? What is the ultimate fate of the universe? And will it continue to expand forever, or will it eventually collapse in on itself? These are just a few of the many questions that continue to inspire astronomers and cosmologists. The universe is a vast and mysterious place, full of wonder and beauty, and the quest to understand it is one of the most exciting and challenging endeavors humans have ever undertaken. As we continue to explore the cosmos, we can be sure that we will make new and astounding discoveries that will challenge our understanding of the universe and our place within it. The universe is a vast and ancient story, and we are just beginning to read its pages.
We began our journey in darkness amidst the unimaginable chaos of the Big Bang. A universe exploding into existence, a maelstrom of energy beyond comprehension. From this primal fury, particles coalesced, stars ignited, and galaxies swirled into being. A cosmic ballet, beautiful and terrifying, governed by forces both elegant and brutal. The journey from chaos to order is a testament to the universe's remarkable ability to create complexity from simplicity, beauty from violence. The very ground we stand on, the air we breathe, the atoms that make up our bodies, all forged in the hearts of dying stars.
Look up at the night sky, a canvas of darkness sprinkled with starlight. Each point of light, a distant sun, perhaps orbited by its own retinue of planets. And on some, perhaps life has taken hold, evolving in ways we can only imagine. It's a story that continues to unfold today. As new stars ignite and new planets coalesce, every new discovery, every image captured by our telescopes adds another verse to this epic narrative.
Our journey through the cosmos has been humbling. We've witnessed the universe's power for creation and destruction. Our planet, a tiny speck, shaped by forces beyond our control. This journey inspires us. The universe is dynamic and ever-evolving, full of surprises and possibilities. New stars are born, and life may be emerging on distant planets. The universe is an ever-unfolding story. Our quest to understand the cosmos is endless.